Welcome to the GOB laboratory at Mercy University. In this experiment, we'll investigate how visible light interacts with colored dyes and how we can use that information to analyze the colorings present in sports drinks. In Part B of this experiment, we'll determine the concentration of blue 1 dye in several sports drinks using a Beer's Law calibration graph and analysis. Here are some of the materials that we'll make use of in Part B of this experiment. Begin by recording the concentration of your blue 1 stock solution on your data sheet. Next, we'll use a 5 milliliter pipette to prepare our Beer's Law standards. Use the volumes provided in the dilution table as a guide. For your first standard, draw up 5 milliliters of your blue 1 stock solution, making sure that the bottom of the meniscus aligns with the calibration mark on the pipette. Then transfer the solution to your first test tube. Now, draw up 4 milliliters of the stock solution and transfer it to your second test tube. This time, draw up 3 milliliters of the stock solution and transfer it to your third test tube. For your fourth test tube, transfer 2 milliliters of your blue 1 stock solution. And in your last test tube, transfer 1 milliliter of your blue 1 stock solution. Once you're done pipetting your blue 1 stock solution, you can recap the bottle and set it aside. For the next part of the experiment, we'll need 25 milliliters of distilled water. Using a clean pipette, transfer 1, 2, 3, 4, and 5 milliliters to your test tube so that the total volume in each test tube is 6 milliliters. The darkest blue will be your most concentrated standard, and the lightest one will be the most dilute. Using plastic pipettes, transfer your standards to cuvettes. Try to fill each cuvette at least 2/3 to 3/4 full of solution. If available, transfer your cuvettes to a cuvette rack for easy transport. If any of your standards appear to have bubbles in them, you can tap them against the bench top to remove the bubbles. Once you're done preparing your standards, you need to calculate the concentration of each solution and record that on your data sheet from least to most concentrated. Next, select 3 sports drink samples to analyze from the samples that have been provided. You'll also need your water blank from Part A. To analyze your samples, you need to make sure that your spectrophotometer is connected to your LabQuest via the USB cable. On the side panel, tap Full Spectrum, and then select Time-Based from the drop-down menu, and then click OK. This will give you access to the live absorbance readout. Now tap the absorbance panel and select Change Wavelength. To analyze the amount of blue 1 dye in each of our samples, we need to set the wavelength to the lambda max wavelength for blue 1 from Part A of the experiment. Now tap on the absorbance panel and select Calibrate to calibrate your spectrophotometer. Again, wait for the lamp to warm up before you insert your blank. As before, make sure that the arrow on the cuvette is lined up with the arrow on the spectrophotometer. Then click Finish Calibration and OK. Remove the blank and insert your most dilute standard to analyze first. Wait a few seconds for the absorbance reading to stabilize and record the value on your data sheet. Our first standard appears to have an absorbance of 0.289. Repeat the process for your remaining dye standards, working from the most dilute to the most concentrated sample. Again, wait for the reading to stabilize and record the value on your data sheet. Our second standard appears to have an absorbance of 0.580. Repeat the same process for your third dye standard, making sure that you let the absorbance stabilize before recording it on your data sheet. This dye standard looks like it has an absorbance of 0.860. As you continue to analyze your fourth and fifth dye standards, always make sure that the arrow on the cuvette aligns with the arrow on the spectrophotometer. Our fourth dye standard looks like it's settled at an absorbance of 1.104. Our fifth and most concentrated dye standard appears to have an absorbance of 1.343. We're now ready to analyze our sports drink samples. We'll again insert the sample cuvettes into the spectrophotometer one by one, making sure that the arrows on the cuvettes line up with the arrow on the spectrophotometer. Our first drink sample of lemon lime appears to have an absorbance of 0.003. Our second sample of fierce green apple appears to have an absorbance of 0.507. Our third sample of Frost Arctic Blitz appears to have an absorbance of 0.241. Our fourth drink sample of Cool Blue looks to have a stable absorbance reading of 0.826. Our fifth sample flavor of grape appears to have an absorbance of 0.261. After you're finished analyzing all of your samples, disconnect the spectrophotometer cable from the LabQuest. Select File, New, and discard any existing data. Now select the Table tab from the top of the LabQuest. This will bring you to a table where you can enter the concentration and absorbance values you recorded for your standards. If the LabQuest doesn't display all of the digits that you type, you can tap the column header to change the number of digits displayed. Under Displayed Precision, select the number of digits you would like displayed and click OK. Enter the remaining concentrations and absorbance values for your standards from your data sheet. Click Done, and then click on the Graph tab at the top of the LabQuest to see a graph of your data. To obtain the slope and y-intercept of your Beer's Law calibration plot, select Curve Fit from the Analyze menu at the top. Now select Linear from the drop-down menu and note the values of the slope and the y-intercept for your data. Use Beer's Law and your value for the slope to compute the molar absorptivity for Blue 1 dye. Record your molar absorptivity on your data sheet and use your value for the molar absorptivity along with Beer's Law to calculate the concentration of Blue 1 dye in each of your drink samples. Be sure to record the concentration of Blue 1 dye in each of your drink samples on your data sheet.